Hello, welcome to Pre-Cal Lecture 1.5. In this lecture we're going to talk about scientific notation, and we're also going to talk about fractional exponents. So with scientific notation, hopefully this is something you've seen before, especially in chemistry. That's usually where it is introduced. It's a way of expressing really large numbers or really small numbers in a truncated way so that you're not having to write out all of those digits. So for example, let's say we have the number 2,609. So the way that we would express that in scientific notation, it's a number greater than 1, so we're going to start on the right. We're going to go 1, 2, 3. We're going to put the decimal, we're going to move the decimal between the first two numbers. So this would be 2.609, and we moved the decimal 3 places, so that would be times 10 to the third. 10 to the third is 1,000, so 2.609 times 1,000 would give you 2609. So in this particular example, it's not easier to write it in scientific notation than the original number is, but let's go with some bigger numbers here. Let's say you have 3, 9, 8, 7, and then 5 zeros. Okay, so it's a number bigger than 1. We'll deal with the number smaller than 1 in a little bit. We'll start at the far right and go 1, 2, 3, 4, 5, 6, 7, and then 8. We move the decimal place 8 spots. We stop between the first two numbers, the 3 and the 9. So we can rewrite this as 3.987. We don't have to write any more zeros. Once you get to the first bank of zeros, you can stop. Now, if there was a zero in between non-zeros, you would have to write that. But when you get to where it's just all zeros, you can stop. And then it would be times 10, and we moved it 8 decimal places. So times 10 to the 8th. So that is a little bit easier way to write this. And the famous number in chemistry would be 6.02 times 10 to the 23rd. You would hate to write all those zeros. So it's in a science like chemistry where scientific notation is really very handy. And then let's do a really small number. How about 0.000132? How am I going to write that in scientific notation? All right, well, what you want to do is you want to move that decimal place 1, 2, 3 until you get to the first two non-zero numbers, and you want to put it in between the first two non-zero numbers. All right, or really after the first non-zero number, because that 3 could be a 0 and that would be okay. So move it to just past the first non-zero number. You moved it 4 spaces, so that's going to be 1.32. So we got rid of all those leading zeros. 1.32 times 10, and because it's a number less than 1, we're moving the decimal to the right. The exponent is negative, so times 10 to the negative 4. We moved it 4 places. Okay, to do that in your calculator, the way that I taught my chemistry students to do it was, and there's more than one way on one of these Texas Instrument 84, TI-84s, but you would do it something like 2.609, that first one we did, and then second function, and then the double E, which is at the comma, and then 3. So 2.609E3, that's the same as times 10. So I found that my students made fewer mistakes if we went with this second double E button instead of actually typing in times 10 and then a caret to whatever power. You can do that but I found they made more mistakes. Let's 2.609 and then times 10 raised to the third power. All right, that also works, equals 2609. So you can do it, you just have to be careful that way. So either way works in your calculator. All right, let's go to section 1.5.2. And remember, you need to be writing all these notes down to keep in a notebook. So converting rational, and rational is just a fancy way of saying fractional. Exponents and radicals. Okay, so let's talk about fractional exponents. Let's say you have our first example, 9 to the 1/2 power. The way you write this as a radical is you would put the 9 underneath the radical. The denominator of the radical goes in the crook. All right, so that's square root. And then the numerator of the fraction, so the denominator of the fraction, I'm not sure what I said. Denominator of the fraction goes in the crook of the radical, and the numerator of the fraction goes underneath the radical. The base is raised to that. Well, if it's a 1, we usually don't write it, and if it's a 2, we don't usually write it, so that's just the square root of 9. The 2 is implied if nothing's written, and the 1 is implied if nothing's written. And of course, that is equal to 3. Okay, so our general rule is if you have root, the square root of n, or excuse me, this is the way to say that would be the nth root of a to the m. The nth root of a to the m is equal to a to the m over n power. Okay, remember, this is denominator, this is numerator of the fraction. And another way, a completely correct way to write that, if you wanted to, it would be the nth root of a, all raised, if you want to put all that in parentheses, to the m power. All of these are the same thing. They're all equivalent. Okay, let's do another example. Let's say we have 8 to the 2/3 power. Okay, that's going to be the cube root of 8 squared, which is the cube root of 8 squared. 8 squared is 64, and the cube root of 64, right, that's going to be the same thing as 64 to the 1/3 power, right? The cube root, that's a 1, that's an implied 1 and a 3, and that's equal to 4. Now, you need to work this on your homework. You need to work these problems without a calculator, but you can certainly check them. And the way to check them is take 64, and then hit this caret symbol, and then do 1 divided by 3 as an exponent, and you'll see that's equal to 4. All right, let me take a second and erase these notes, and we'll continue on in section 1.5.2. Very short lecture today. Hopefully it's all review. Let's see, our next example, let's say we have the square root of 2 times the cube root of 2. Okay, the way I want to rewrite those is as fractional exponents. So the first one is 2 to the 1/2 power, square root's always to a 1/2 power, times 2 to the 1/3 power. Well, when you have the same base, what you do is you add the exponents when you multiply. So it'd be 1/2 plus 1/3. So that's just going to be equal to 1/2 plus 1/3. If you get a common denominator of 6, you would be at 2 to the 5/6 power. So we could, if we needed to write that as a radical, it would be the 6th root of 2 to the 5th. Okay, so I didn't really give you instructions there on that example. I was just showing you how all of that works. So depends on the question. If it's asked you to write it as a radical, you do that way. If it doesn't ask you to write it as a radical, then you can leave it as a fractional exponent. In calculus, we work with fractional exponents. So the ability to take from this to this is very useful, and then we can do the calculus. All right, so the next example is we want to simplify, and that would have been the instructions on the previous example as well, of quantity 3x to the negative 1/2 power. Well, we want to rewrite this with a positive exponent. So that's going to be 1 over 3x to the 1/2 power. And then we can rewrite anything to the 1/2 power. If we want to do it with a radical, that would be 1 over the square root of 3x. Now, some mathematicians don't like you to have a radical in the denominator, and they want you to get rid of that radical, and we'll go over how to do that soon. Okay, so you could leave it either like this, or if the instructions are to get rid of fractional exponents, you'd have to write like this. All right. The next example, we want to evaluate (25 to the minus 3/2 power). Well, the easiest way to do this, and you know, your calculator can take care of this, but I want you to show your work. That's going to be 1 over 25 to the positive 3/2 power. If we were to rewrite that as a radical, the 2 goes in the crook of the radical, but it's implied, so we don't write it. 1 over the square root of 25 cubed. Okay, 1 over the square root of 25 cubed. Well, you might not know what the square root of 25 cubed is, so we could go ahead and get a little help from our calculator here. 25, I'm going to raise that to the 3/2 power. That's 125. So the square root of 25 cubed is 125. So when it says evaluate, we're just trying to get you to get it down to a single number or a fraction in this case. This would be 1 over 125. All right, next example, we want to simplify y to the 1/8 times y to the 3/4. Well, what do you do when you have the same base and you're multiplying to different exponents? You add those exponents. So this is y to the 1/8 plus 3/4. Now we need to have them both in eighths, so that'd be y to the 1/8 plus 3/4 is the same as multiply that by 2 over 2, right? And that would be 6/8. So that's y to the 7/8. And if I were to rewrite that as a radical, again, just follow the instructions. That would be the 8th root, because the denominator goes in the crook of the radical, of y to the 7th power. All right, so depending on what the question is asking, you're looking at one of those two answers. All right, just a couple more examples. So our next example is we want to divide x to the 1/2 by x to the 1/4. So we could rewrite this just simply as x to the 1/2 over x to the 1/4. Well, when you're dividing the same base to different exponents, you would subtract the exponents. So this is the same as x to the 1/2 minus 1/4. So that's 2/4 minus 1/4. So that would be x to the 1/4, or the 4th root of x, whichever way you are asked to report the answer. And then our last example is divide x to the minus 1/4 by x to the minus 1/2. So that's x to the minus 1/4 divided by x to the minus 1/2. And again, you're just subtracting, so that's x to the minus 1/4 minus negative 1/2. Well, two negatives make a positive, so that's x to the minus 1/4 plus 1/2. Negative 1/4 plus 1/2 would be x to the positive 1/4. So the same answer as the previous example, or the 4th root of x. Okay, so your homework is going to be worksheet 1.5. And just looking over that, you've got a few scientific notation problems, and then the similar problems to what we just did. Just simplify them. Go ahead and take them all the way out if required. So for 5 through 8, I'm looking for a fractional answer. So what I'm looking for is, your final answer might be 1/64. That's not true on any of these problems, but something like that. Okay, so go ahead and do like the example where the answer was 1/125, so 1/64. And then with 9 through 12, those are all like these last two examples. So give the answer in both fractional, exponent, and radical form. So do just like I did on the examples. You'll end up with a fractional exponent, and then go ahead and put it in radical form as well, because that's good practice for you. In calculus, the textbook will give you the radical form, and you have to then convert to the fractional exponent form before you can perform the calculus. So this is a useful skill to have for your future. All right, I hope that lecture helped you, and I will talk to you on the next video.